Alright guys, welcome to this page of the notes. So what we're going to do is we're going to keep going with this idea of using the square root property to help us solve a quadratic. But now what's going to happen is, unlike the previous examples where we had these nice perfect squares show up and everything worked out to these nice neat answers, it rarely works out that way. In fact, most times you're going to wind up with a quadratic that doesn't have perfect squares in it, and you're going to have to approximate your answers or leave your answers as radicals, right? We were getting things like the square root of 36, right, which of course is plus or minus 6, or the square root of 49, which of course is plus or minus 7. But what happens when you get the square root of 5 or the square root of 12, right? Those are not perfect squares. In fact, you take the square root, you're going to get an irrational number, right? So what do we do when you wind up with these irrational numbers? So let's work through these example problems and we'll show you what we're going to do with these. So I've got this guy right here. I recognize that it is a trinomial. Very nice. 16 is actually still a perfect square. That's not the issue. It's the 5 over here. When I recognize, if you're thinking ahead, right, you know that you have to take the square root of both sides, and I'm going to wind up with the square root of 5. 5 isn't a perfect square. It's going to wind up being an irrational number. So that's why these ones are in here, and we'll take a look at what we're going to do with that. But for now, I've got a trinomial. 16 is a perfect square, and my leading coefficient is 1. So we just jump straight into two binomials. Going to need an x and an x. Since 16 is a perfect square, these two numbers are going to have to be the same. I need two numbers that multiply to 16, sum to a negative 8, and of course it's going to be minus 4 and minus 4, which means I'm going to have x minus 4 squared is equal to 5. Take the square root of both sides, and this is where we run into our problem. 5 is not a perfect square. In fact, the square root of 5 is going to be an irrational number. Now, hence why I tell you up here, we're either going to leave our answer as in what we call radical form, or if you have a calculator, you certainly could plug the square root of negative 5 into your calculator. You would have to round, and in most cases, if I ask you to round, I'll ask you to round to 2 decimal places. But if you're taking this class with me on my tests or quizzes, I will not put the square root of 5 into a calculator and get the decimal form. I will always. I think they look nicer when they're left as a radical rather than giving you a decimal that I've rounded. So I will give you both answers here in the notes, but just know on a test or a quiz, I'm more than likely going to leave it in radical form. I just like it better. I got to add that 4 to the other side. And like I said, you get two answers. I get x is equal to 4 plus the square root of 5, and x is equal to 4 minus the square root of 5. And like I said, if you were to plug this into your calculator, which you certainly could, I actually have already done that, I get x is equal, again rounding to 2 decimal places, 6.24, and x is equal to 1.76. If you were to plug those into your calculator. Again, these represent the x-intercepts, where your quadratic, right, because this is a quadratic, it represents a parabola. This is going to be where your parabola crosses the x-axis. Let's try another one. Once again, I recognize I have a trinomial. 25 is a perfect square, and my leading coefficient is a 1, so we just go straight to our binomials. Okay, since 25 is a perfect square, I need two numbers that multiply to 25, sum to a negative 10, and they have to be the same number because 25 is a perfect square. It's going to be a minus 5 and a minus 5. And I can see my issue. 27, of course, is not a perfect square, so I can see where this one's going to be a little tricky. We'll get to it, though. Take the square root of both sides. Don't forget to do plus or minus. And then I add 5 to the other side. 5 plus or minus the square root of 27. Now, here's what I am going to ask you to do. Again, remember, I prefer to leave my irrational, my my non-perfect squares in radical form. That's what I would prefer. However, I absolutely want you to reduce those radicals if you can. And in this case, we can. 27 is the product of 3 times 9. And 9 is a perfect square. Take the square root of 9 and I get 3. This is in simplest form. It is absolutely what I need you to put your answers into. Put them in simplest form. Leaving it like this is not acceptable for Algebra 2 students. At this point, you should be very comfortable with simplifying radicals this way. If you can split it up, split that non-perfect square up into factors that where one of them is a perfect square, you absolutely should do that. And so now in this case, I get 2 solutions. And once again, I have done this for you, or I will do this for you, where I give you the decimal form, even though I don't really like it. And like I said, on a test or a quiz, I will almost certainly leave it in radical form. But if you were to throw that into your calculator, you would get 10.20, rounding to 2 decimal places, and x equals 5 minus 3 plus the square root of 3, which would be negative 0.20. I got a couple more for you, so let's try another one here on this page of the notes. And once again, we're going to factor using, solve using square root property. I have a trinomial, perfect square, leading coefficient of 1, binomials. Take the square root of both sides. Okay, 20 is not a perfect square, but I can factor 20 into something that is a perfect square. In this case, I would do 4 times 5. Four is a perfect square. It's going to be a 2. So you wind up with x is equal to negative 4 plus or minus 2 square roots of 5. That is as simplified as you can get. And I did give you, you would have negative 4 plus 2 square roots of 5. And you'd have negative 4 minus 2 square roots of 5. And I do have those as decimals, 0.47 and a negative 8.47. Awesome. I got one more for you here. Again, at this point, hopefully you are more than comfortable with these and you have already worked ahead and you're just coming back to check your answer. So welcome back. Let's see if you get what we get. What I get. Trust me, there's nobody else here. It's just me. I'm all by myself. But I'm glad you're here. Let's see. I'm going to need a minus 3. No, minus 3. X minus 3 squared. 32 is definitely not a perfect square. Plus or minus square root of 32. Add the 3. All right, what can I split a 32 up into? 16 and 2. Sixteen is a perfect square. And so we wind up with x equals 3 plus 4 square roots of 2, and x equals 3 minus 4 square roots of 2. And again, if you got a calculator there with you and you were to throw those in, rounding to 2 decimal places, you would get 8.66. And x equals negative 2.66. Guys, that takes care of the problems here on this page of the notes as far as using the square root property to solve quadratic equations. So what we're going to do here on the next page of the notes is we're going to begin to take a look at this idea of factoring by completing the square. So I'll meet you on the next page of the notes.